Hi everyone, welcome back to our YouTube channel InfinityGreedy. In our today's video, we are going to trace an example on quicksort and we'll understand how actually we select pivot, how we do partitioning, and how we do a recursive call, and how actually the complete this quicksort works with the help of an example. For example, I have an array with element 21, 12, 41, 9, and 27. So the step one, what I do, I'll just write basic steps, right? A basic flow of my algorithm. What we do, we basically check whether pivot is greater than a of I. I don't know what is a of I, I'm just writing it. If this is true, I will increment I. If this is false, I will check pivot is less than a of j. If this is true, I will decrement j. If this is false, I will swap. Now what I'll swap based on checking the condition I less than j. If it is true, what I'll swap a of I with a of j. If this is false, I will swap pivot with a of j. Do not bother about what I have written here. It's just I have written the algorithm to trace. Now let's get started. How we will do it. Okay. So step one. Step one is just write the algorithm array 41, 9, 27 and add infinity. Now add infinity at the end. Now when you add infinity at the end, what is the purpose of this? Let me explain. This acts as a boundary condition. If you see, infinity is the largest element, and largest element actually will come at the end or in the sorted array also. So this, if you think it is already sorted, so it helps as a boundary condition where to stop. So if you reach by this element, you need to stop. Because if you remember in our previous video, I was talking about Horace partition where we slide I and j. Now till this I will get till where? It has to stop somewhere, right? So it will stop here. You cannot increment I beyond this. You have to stop here. So this infinity will help you. This condition will help you. You will not get any increment of I with this infinity, right? So that is why you add infinity. Then step 2 is select pivot. So select pivot, so I'm considering first element as my pivot. So first element as pivot. So this is what I'm selecting. I'm selecting first element as pivot. Then initialize I and j as low and high. So what I do, I basically consider this as my low and at the end as high. So I will initialize I like this, I as this and j as this. Now you may ask a question, do we need to add infinity? No, there is no need to do this. Do we need to initialize I to the first element? No, you can initialize I to this also. But the right, but the good way, because many a times there is confusion occurs. So to avoid all this, this is what I do. I consider first element as pivot. I initialize I and j as first element and the last element, right? Then get started with the array. Step 3 is to get started with the array. So what is array? First you check this condition. Pivot is greater than or a of I. Pivot is what? 21, because this is a first element. This was your pivot, right? So is 21 greater than or equal to 21? Condition is true. If condition is true, what you do? You increment I. So cross this I and increment I to this index. So I is the index, remember that. So let's say I have given the index name also 0, 1, 2, 3, 4 and 5. I have incremented I. Now I becomes equal to 1. Then again you check if 21 equal to greater than or equal to 12. Condition is true. It is greater than. So again increment I. So I comes here. Is 21 greater than 41? condition is false. If condition is false, what you need to do? You need to check whether pivot is less than A of J. What is your pivot element? Your pivot element is 21. Is it less than infinity? Because A of J is what? Infinity. Condition is true because infinity is the largest element. So what you need to do? Decrement J. If this condition is true, what you need to do? Decrement J. So J becomes this. Now 21 is less than 27. This condition is also true. So decrement J again. Now is 21 less than 9? This condition is false. So if this condition is false, you need to do a swap. So second times false. Once you get false here, second times you again got false. What you need to do? You need to swap. Now what you need to swap? You need to see whether I has crossed J or not. That is, I is less than J or not. So what is the value of I is 2. What is value of J? 3. So this condition is true. If this condition is true, what you need to swap? A of I with A of J. So you need to swap this with this. A of 2 with A of 3. That is 41 and 9. So you swap 41 and 9. So when you swap 41 and 9, what your array will look like? 12, 9, 41, 27 and infinity. And your I was here and your J was here. Those remain same. And your pivot was this. Right? Then again get started. Is pivot greater than A of I? Again get started with this. Okay? Until and unless you get the partition. You did not get the partition, right? You just get the swap. So 21 is greater than or equal to 9. So that is what? I was here, right? So is 21 greater than? Condition is true. So increment I. Is 21 greater than or equal to 41? Condition is false. When condition is false, what we do? We check for pivot is less than A of J. What is pivot? 21. Is it less than J is what? 41. Condition is true. So decrement J. So J becomes this, right? Now again, 21 is less than 9. Condition is false. When both false happens, what we do? We swap, right? So that is what. So we have checked this. Now this is also false, so swap. Now swap. If I is less than J, then so what is it? I has crossed J. Here I is what? 0, 1, 2, 3, 4, 5. So I is 3, J is 2. So I less than J condition is false. So what you need to swap? You need to swap pivot with A of J. What is pivot? 21. What is J? 9. So when you swap this, you get 9, you get 12, you get 21, you get 41, you get 27, and you get infinity. Now this is your pivot. Now if you see, this pivot has got its right position. So this pivot is sorted. This pivot is sorted. So you have got the partition. That is part 1, part 2. Now you have to again apply whatever same approach here and same approach here. That is, you need to apply quick sort again here, quick sort again here. This is what called as recursion. Let's do that. Are you understanding this much? So once you swap pivot with A of I with J, then your pivot gets to the right position and we need to stop because you have placed the pivot to its right position. In a sorted array, 21 position is at right. So when you sort this, right, actually what you will get 9, 12, 21, 27 and 41. So you see the index 2, at index 2, 21 will come and it has rearranged. Now all the elements to left of it are less than 9 and 12 are less than 21 and all the elements left to it are greater than 41 and 27. That is also right. That is what partition says. Are you getting it? It means you have placed the private element at its right position. Make sense? Now let's apply quick sort on this and this, right? Now, whenever you take this, you can take this pivot element with it. That is, you can apply a quick sort again on this subarray, and here you can apply quick sort on 27 and infinity. Why I have clubbed this 21? Because I know this is already sorted. So this will act as my boundary condition. And for this boundary condition, I have already taken infinity, which is again sorted. Make sense? So what we'll do, see, if you see it is already sorted, but you need to apply a quick sort, right? You need to check that. Okay. So what you consider? Consider this as my pivot element. Step 2, what we do, we initialize I to this and high as j. So what we'll do, we'll check whether pivot is greater than a of I. We'll get started with this. So 9 greater than equal to 9. Condition is true, increment I. So I becomes this. Is 9 greater than or equal to 2? 12. Is this is true? 9 is greater? No, false. If this is false, what we do? We check pivot is less than a of j. So pivot is less a of j 21. Condition is true, decrement j. Now you should quickly work on this, right? So this becomes your j. Is 9 greater than 12? Condition is true, again decrement j. Then j becomes this. Is 9 greater than 9? Condition is false because this is true. Well, this is false. 9 is equals to 9. It's not less than. The condition is false. So when you get two false, what you do? You swap. Now you need to check whether I has crossed j. Yes. So I is less than j is wrong. It is false. So what is false? We do pivot with a of j. Now what is pivot? Pivot is 9. What is a of j is 9. So if you swap 9 with 9, you will get 9 only. So it remains same. 9, 12, 21. So the pivot remains same. So this was your pivot. So 9 was your pivot. Now there is no element left to it. There is only one element right to it. So we do not need to do anything. You remember where we have to stop? When we get subarray of only one element left. There we need to stop. So this is sorted. This is sorted. This was already sorted. Now we need to sort this, right? So can I utilize this space here only? Okay. So what we do? Let's consider this as pivot, this as I, this as j. Now let's do quickly. Pivot less than 41 is greater than 41. Condition is true, increment I. So increment I. Is 41 greater than or equal to 27? Condition is true, increment I. Is 41 greater than infinity? Condition is false. Check pivot is less than a of j. Is 41 less than infinity? Condition is true, decrement j. So j becomes this. So is 41 less than 27? Condition is false. If both are false, what we do? We do swap. Now I has crossed j, means we need to swap pivot with a of j. Pivot is 41. What is a of j? 27. So if you swap this, you get 27 here. Pivot with this, and you get infinity. Now if you see, only there is one element left, right, in the partitioning. So you need to stop here. So at the end, what you get the sorted array as 9, 12, 21, 27, 41. So this is infinity you can remove now because we don't need it now. So the question can be, how many pivot element you need? You need 3 pivot element. So you need 3 pivot element, right? And your array is sorted. Did you understand this algorithm? So let's practice more examples so that all these things comes in your hand, right? And it is easy for you to trace the algorithm. So let's take one more example after this video and solve it again. And then we'll going to write the actual algorithm code, how it looks like. Because now from this you might have got an idea. but we'll write in a proper way. We'll write the functions, and then we are going to derive time complexity, space complexity for the same, and we'll practice more questions. After that, we'll see what are the advantages and disadvantages of this algorithm, followed with the application and most important interview question asked. Right? So if you like this video, please do like, share, and subscribe. Thank you.